For the rest of week 7, we continued our conversation about the properties. In particular, we continued to look at the order in which we add, subtract, multiply, and divide numbers. Now, if we recall, the order in which we added numbers did not matter. And so 3 plus 7 was equal to 7 plus 3. This became the commutative property of addition. Now we remember that when we talk about a property, we had to talk about the operation. Now, when we look at subtraction to see if there's a commutative property of a subtraction, we say is 3 minus 7 equal to 7 minus 3? Well, 3 minus 7, I can also write this as 3 minus 4. And so these are going to cancel out, and I get negative 4. So negative 4 is 3 minus 7, and 7 minus 3 is positive 4. Now, negative 4 is not equal to positive 4. Actually, negative 4 and positive 4 are opposites. So, we have some information about that, and we want to look at some theories, investigate some theories about opposites. So, when you add negative 4 and 4, what will happen? Well, negative 4 plus 4 is 0. And if we looked at negative 6 and 6 and added those, we get 0. If we looked at 10 and negative 10 and added those, we get 0. And what we can generalize is saying, we can generalize this by saying adding opposites results in 0. Now, we can also test some theories about 0. So, negative 4 plus 0 is equal to negative 4, and 4 plus 0 is equal to 4. Now, 10 plus 0 is equal to 10, 100 plus 0 is equal to 100, and we can say adding 0 to a number does not change the value of that number. If adding opposites always results in 0, then we can generalize this idea using a property, just as we did the commutative property of addition and the associative property of addition. So here, we're going to say a is any number, and negative a is the opposite of that number. And if we add a and negative a, we're going to get 0. So because we are using addition, we're going to call this an additive property. And what we're actually doing here in this additive property is adding opposites. And these opposites are actually called additive inverses. So we get the additive inverse property because when we add inverses, we get 0. Now, here we have the sum of any number and its opposite is 0. The second thing that we did was we tried to say something about adding 0. So here we see if it is true that adding 0 does not change the value of a number, then we can also generalize that with a property. So here we have a, which represents any number, plus 0 is going to equal a. Now, here on one side of the equal sign, the left side of the equal sign, I see a plus 0, and I see a. And here on the right side of the equal sign, I see a. So a plus 0, this entire expression, is equal to a. These are mirror images of each other after adding 0. So the number keeps its identity, a on one side, a on the other side of this equal sign. And it keeps this identity because we added 0. So what we say about 0 is that it must be the identity of addition. So because we are adding, just like last time, this is an additive property. And what we are doing is adding the identity of addition. So we get the additive identity property. The sum of any number and 0 is that number. Now, if 0 is the identity, we can come back over here and we can say the sum of any number and its opposite is 0, but 0 is the identity, so we can say the sum of any number and its opposite is the identity of addition. We should just specify. And so we have our inverse property, which says when we add inverses, we get the identity. And we have our identity property, which says when we add the identity, the result does not change.